Hello everyone. So today we are going to solve problem number 1326, minimum number of taps to open to water a garden on LeetCode. So let's first read the problem statement. There is a one-dimensional garden on the x-axis. The garden starts at point 0 and ends at point n. That is, the length of the garden is n. There are n plus 1 taps located at points 0, 1, 2, 3 till n in the garden. Given an integer n and an integer array ranges of length n plus 1, that is from 0, 1 till n. So there are n plus 1 elements. Where ranges at I, that is 0 indexed, means the ith tap can water the area from I minus ranges at I till I plus ranges at I if it was on. So if we turn the ith tap on, it can water the area from starting till end. Return the minimum number of taps. So this is what we need to return. The minimum number of taps that should be open to water the whole garden. If the garden cannot be watered, return -1. So let's look at the first example. So here they have given n equals 5. That means our ranges will be from 0, 1, 2, 3, 4 and 5. So the range of for the 0th index, that is 3. So this step can water the area from 0 minus 3 till 0 plus 3, that is -3 to +3, which is shown here, -3 till +3. And for index 1, it can water the area 1 minus 4 to 1 plus 4. That means -3 to 5, which is shown with this. Similarly, the tap 2 can water the area from 2 minus 1 to 2 plus 1. That is 1 to 3. That is shown with this. Then the tap at index 3 can water area from 2 to 4, but we see that for tap number 4 the range is given 0. That means it can only water this point, that means number 4 only, and this can water only number 5, but we have to water the whole area. That means from 0 till 5 we need to water this, every the point that is coming in between, we need to water them also. That is why the second example, 0, 1, 2, 3, the first tab can water the area in this, the single point, second tab, third tab and fourth tab. So here we see that the whole area is not covered, only few points are covered in the whole garden. So that is why we cannot water the whole garden even if all the four tabs are on. The time complexity here is 10 to the power 4. No, the value of n here is 10 to the power 4. The range of length is n plus 1, and ranges at I can be only from 0 till 100. So how can we solve this problem? If we observe carefully, we can see that for every index we have got certain range. That means the area of garden this can water. So what we can do, we can first calculate all the ranges. That means -3 to 3, -3 to 5 and all. Then we observe the only useful ranges for us are from 0 index until 5. So what we'll do, we'll make an array of size n plus 1 having index 0 till 3, 4 and 5. And in each index, what will store? We'll store the maximum value, because we see for the 0th index there are two values, 3 and 5. So in each index we will store the maximum value we can go from this index, the maximum range we can get from this index. So for 0th index we are getting range of 5. For first index we are getting a range of 3. Similarly for second index we are getting a range of 4. For third index, okay, for third index we are getting a range of 4. No, no. Okay. For third index we got nothing, and similarly for fourth index we got nothing, and similarly for 5 index we got nothing. We will not put this 4, will not consider these points because they are only watering a single point, so we don't need to consider them. So when we see that the range is 0, we will skip them. So after we have calculated all the ranges, the problem becomes very simple. We simply need to calculate the number of indexes to be taken to cover the whole range. And this problem is now very similar to the jump game 2. Here what we do, first we take the minimum, or we can say the first index, and here what we have we try all the indexes we can reach from the current ending. So the current range is from 0 till 5. Now we will take the next step or open the next tab where we can get the maximum range. Suppose if there was some other elements, so we would have one element was going from here till here, another element was going from here till here, and another element was going from here only till last. So we would have taken the range that covered the maximum ending point, because here we have many options like this. So we'll start from this position 0 and go till the current ending. And because from starting till here and going till end we need to only open just one tab, and if we need to open the second tab we will take the maximum among these, then our ending will increase, and from there we'll search for the third tab, that which tab we need to open. So the intuition is very similar to the that of jump game too. Now let's see how to code it, and there it will get more clearer. So what we need is, first we need is some array to store the ranges. So what we'll do, we'll take a vector of integer type, let's call it a, of size n plus 1 as we have seen before. Then we need to fill this range. So what we'll do, we will traverse I from 0, I less than equal to n, because the index of ranges will go from 0 till n. Now first we need to encounter the condition that if ranges at I is equals 0, that means it can water only a single point, we don't need to consider it. So we will simply continue. Then we will calculate the left range and the left point and right point of the current range. So in left will be maximum of 0 and I minus ranges at I. So what we are doing here is we are trying to take the maximum between 0, that is here, and this, because if we do not do this, our index can go in negative direction, and a negative index is not possible, which will cause an error. So we are taking the maximum of 0 and the range they can go. Then we will get the right index or the right range, and that will be nothing but maximum of, it's not maximum, it's simply I plus ranges at I. So each range is going from I minus ranges at I till I plus ranges at I. And now what we'll do, we will place this at the ith index, or you can say the lth index, that is the starting position. For every starting position, what we'll do, we'll take the maximum it can go for the right position. So it will be nothing but a at starting position and the current value or right. So here in example we see for the 0th index we will get 0 till 3, and for again for the second index we will get this 0 value, so 0 till 5. So finally at the in the array we will store 5 at 0 index. So now our array is filled. What we need is we need a variable for answer and a variable to store the reach, the current reach we can get. So we'll initialize it with 0, and the current ending we secret current and it will be also 0. Now we start from the 0th index and we will go till the last index, but also we need to check if our current end is less than n or not, because if this condition is met we don't need to check other values because we have already filled the whole garden with water and we need to stop. Then at each step we will update our current ending with the maximum reach we can get. And what we'll do inside the loop, we'll first increase our answer because we have chosen a tab to open. Next what we'll do, we will loop while our index is valid and I is less than or equal to current end, that means the index where current is ending. And in this what we'll do, we will update the reach with maximum of reach and rate I plus plus.